Okay. Excuse me. All right, we left off with the deck of cards, and I think I told you that when we're working with the deck of cards, you've got to know the deck of cards. You can't just, you've never seen a deck of cards or you never fooled with a deck of cards, then you need to go back to this screen in the notes, and you need to make sure you know the deck of cards. And I say that loosely because there's some people that don't know anything about a deck of cards. So make sure that you either get a deck of cards or you use this slide right here and take a picture of this slide or pause it and do something to try to learn the deck of cards if you don't know it. Most people do know it, but just in case, there it is. The deck consists of 4 suits. Each suit has 13 cards, including number cards, blah, blah, blah. Hearts and diamonds are red. There are 12 picture cards consisting. 1 card is to be selected at random from a deck of cards. Determine the probability that the card selected is an 8. So we know that there's 2 black 8s. Let me get my, hold on. Let me get my, okay, we know that there's 2 black 8s in a deck of cards, and we know that there is 2 red 8s. And this is the kind of thinking, heck gum, I just dropped this pen twice. We know that there's a red set of 8s. So there's 4 in a deck of cards. So therefore, the probability of picking one of those 8s would be 4 over 52. Now remember, I said I'm not going to worry about y'all being able to reduce a fraction. You should be able to reduce that down to 1/4. So that would be 0.25. So the probability of picking an 8 would be 0.25. So that's a test question. Let's do not an 8. Well, if the probability of not an 8, and we talked about this with the complement, if the complement, if the probability of getting an 8 is 4 out of 52, then the complement of 4 out of 52 would be 48 out of 52. And that would be 3 over 4, which is equal to 0.75. And that is a test question also, because the complement is very important on standardized tests. So make sure you understand what the complement is. It's what makes up the whole. The whole deck is 52 cards. So if this is 4, then this has to be 48. If this was 10, this would have to be 42. If this was 20, this would have to be 32, and so on. A club. Well, we know that there are 13 clubs in a deck of cards. So that would be 13 over 52, which would be, oops, I messed up. I think this would be 1 over 13. And this would be 3 over 13. So I need somebody, well, I'll do it. Let's see, calculator, 1 over 13, 1 divided by 13 is equal to 0.07. So this would be 0.93. Okay? Now, 13 over 52 would give you the 1/4, which would be 0.25. So if I asked you, what is the probability of not picking a club, and I put an X through it, then that would be 36. Let's say 13 times 3, 39. That would be 39 over 52, which would be 3 over 4, which would be 0.75. Okay? Now, they didn't ask that, but I did, because you got to understand the complement. A jack, let me see if that says a jack or a queen. I think it says a jack or a queen, or a jack, king, or face card. Okay? They want to know a face card. How long of a delay we got? Can y'all see 0.75? Can y'all see 0.75?
Yes, sir.
Okay. Mr. Diggler, are you there? Mr. Dingler. Make sure he's here, because he texted me. Hello, Mr. Dingler. Yeah, I'm here. Okay, well, you can't. Is there something wrong with your computer? Just type in on the chat if you can.
Priority 1 message coming in on...
Oh, audio problems again. Okay. So you can hear me. As long as you can hear me, we're good. Okay. So a face card. Probability of a face card. Probability of a face card, well, we know that there's a king, queen, and jack, black, king, queen, and jack, black. We also know there's a king, queen, and jack, red, king, queen, and jack, red. So that will be 4 times 3, which is 12 over 52. And 12 over 52, I'm just typing it in my little Sally Homemaker phone calculator. 12 divided by 52 is 0.23. So the probability of not a face card put an X through that would be 40 out of 52, and you just subtract that from 1, and that would be 0.77. So all of these questions that I'm doing right now are going to be test questions for y'all, because I'm not going to get too in depth with the probability. This is an introductory section, so I'm not going to get too in depth. A heart and a spade. Well, that would be 0. Now somebody tell me why it would be 0. A heart, probability of a heart and a spade. Why would that be 0? Why would that be 0? because you're only allowed to pick one card. You're only allowed to pick one card. And why would it be 0?
Because it could not occur.
Because it cannot occur because this says and. So that means you got to draw twice. Okay? So the reason they put this, they didn't put this in here to trick you. They put this in here because in probability, you have to read and you have to think about what the question is asking. Okay? And means that you're picking 2 cards. So that would be 0. And a card greater than 5 and less than 9. Greater than 5 and less than 9. I don't know what's going on my computer. Okay, so let's look at that. Greater than 5 and less than 9. So 6, 7, 8. 6, 7, 8. This is probability of a card being greater than 5 and less than 9. Greater than 5 and less than 9. So that means red, we would have 6, 7, and 8. And another 6, 7, and 8. So again, 3 times 4 is 12. So that's 12 over 52. And I think we said 12 over 52 was 0.23. Now be very careful here, because I could easily do this on a test. Probability of a card being greater than or equal to C, greater than or equal to 9. That would be 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. So that would be 5 times 4, which would be 20 over 52, which would equal 20 over 52. 0.38. These are exclusive, meaning you can't use 5 and 9. This is inclusive, meaning that you can use 5 and 9. So that's 2 more test questions, or that's another test question right here that I could ask. Question on that. Now, let's see what they get. One over 13. Not an 8 would be 11 over 13. I'm sorry, 12 over 13. A club would be 13 over, which is 1/4, 0.25. A jack queen, we said that that was 12 over 52. A heart and a spade. The word "and" means both events must occur. This is not possible. Remember us doing the probability of a 7 on a die? That's the same type question. You can't have a 7 on one die. A card greater than 5 and less than 9. 12 over 52. Okay. Now let me go to odds. Well, I thought it pulled up odds. I guess it didn't. Let me go pull up odds. Sorry. Should be odds. Now, the thing you got to deal with odds is you want to keep everything a fraction. Okay? You want to keep everything a fraction. Write that down. I'll write that down while y'all write it down. With odds, you want to keep everything in fractions until you have the answer. Okay, let me just bring that up right quick. If you're dealing with odds, you want to keep everything a fraction until you have the answer. All right? Will you stop it? I got a crazy cat in here. All right? Now, mostly when we're dealing with odds, you're going to be dealing with odds against. Okay, the opposite, the reciprocal of odds against is odds in favor. Odds against is equal to the probability of success, of failure, over the probability of success, or the probability of winning over the probability of losing. The probability of losing over the probability of winning. Okay, let me rewrite that. Probability of losing over the probability of winning. And the probability of odds in favor is the reciprocal. Probability of success over the probability of failure, which is the probability of winning over the probability of losing. Okay, so make sure you got that written down, because we're going to do some problems with odds against. Now, the reason that odds against is the ones that's most tested, or the ones that's most used, is because the odds against is used with gambling. Okay, that's what all the casinos use to decide how much money you win on a bet, or a horse track where you bet on the horses. So let's do an example. Let's say that you have a deck of cards and you want to bet people on picking a face card. No, let's say a king. Probability of picking a king. And A, we want the odds against, This is what the question is going to ask you. B, what would happen if you bet $500? Okay, so this is the type question you would see on a test. So how do we do it? Well, we got to do the probability of a king first. We know that the probability of a king would be 4 over 12. Now you can reduce that if you want to. I'm sorry, 4 over 52. And you can reduce that down to 1 over 13. Now, in order, you got to know what is winning. And we're going to color this green. And we're going to say that this is the probability of winning, because the bet is based on picking a king. So that's the probability of winning. So what is the complement of winning? Losing. So I'm going to take my red pen and I'm going to say, therefore, the probability of losing is equal to 12 over 13. Now that's very important that you do that on this question, because those two fractions, 1 over 13 and 12 over 13, that dictates how you do the odds against. So odds against would be the probability of losing over the probability of winning, which is going to be equal to 12 over 13 divided by 1 over 13. And when you divide by a fraction, you multiply by the what?
Reciprocal.
And the 13s will cancel, and that will happen every time. That's why you need to leave it as a fraction, so that way the 13s will cancel out. So the odds against winning, or the odds against a king, is 12 over 1, or 12 to 1, or 12 to 1. You can write odds against 3 different ways. So that's B, 12 to 1. So what happens if you make a $500 bet and you get a king? So you take 500 over 1 multiplied by 12 over 1. You always multiply your bet. You multiply your bet times your odds against. And you take your calculator, and I think it's going to be 6,000, but I want to check. That's going to be 12 times 500. $6,000. So you walk home with $5,500. Now, I want to go up here and I want to write down 1 over 13. It's 0.07. This right here is 0.07. What do you think about 0.07? Is that a very low probability or a very high probability? What do you think? Very high or very low? Y'all can talk to me. One of you can. Mr. Yap, is that a very high probability or a very low probability? 0.07. Is it closer to 0 or is it closer to 1?
It's closer to 0.
So therefore, it's a very low probability. So if your probability of winning is low, the odds against will be high. Therefore, you win big. I mean, how many of you would say that turning $500 into $6,000 is a pretty good bet? That's a pretty good bet. So if the probability of winning is low, then the odds against will be high. And if the odds against will be high, and you pick that card, you will win big. Now let's do another example and see what happens when we pick a card that is less, has a high probability. Okay, so here we go. What about the probability of picking a card, probability of a card greater than or equal to an ace, less than or equal to a 10? Okay? And we'll put a CE right here so you know what that means. That's a 1. Okay, so let's think about this a minute. A, I want to find the odds against, and B, I want to place that same $500 bet. So let's do the probability. Well, first of all, we got to write down the cards and see. Let's see. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then red, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 4 is what? 40, Hubert.
40.
40 over 52. Okay? Now, I'm not going to reduce that. I'm just going to leave it like it is. Okay? So, the probability, ace less than 10, and I put red through that. So, what's the probability of not getting? Well, that'd be 12 over 52. So that's equal to the probability of losing, and the top one is the probability of what? Winning. Put that in red. So let's do the odds. Odds is equal to the probability of losing over the probability of winning. So that's going to equal 12 over, I'm sorry, yeah, 12 over 52 over 40 over 52. And what do you do when you divide by a fraction? You multiply by the what?
Reciprocal.
Mm-hmm. And of course, the 52s cancel like they're supposed to. And that leaves you with 12 over 52. I mean, it's 12 over 40. Now you can reduce that if you want to, or you can turn it into a decimal. So 12 divided by 40 is equal to 0.3. So that's your odds against. 12 to 40 odds. Now if you need to write it as a fraction, 2 will go into there, 6 over 20 and 3 over 10. So that would be 3 over 10 or 3 to 10 or 3 colon 10. 3 to 10 odds. So we make a $500 bet and we pick that card. We pick a card. So that would be 500 times 0.3. And we multiply by 500 and we get $150. I've done something wrong. That's not right. It can't be right. I've done something wrong. You're supposed to win more than $500. I think I've done something wrong. 500 times 0.3. 500 times 3 divided by 10. I guess that is right. You lose money, basically. I might have made this too big. This might be too big. But the whole point is, the probability is high. So you write down the probability is high. The probability of winning is high. Because 40 over 52, what is that? 40 over 52. 40 divided by 52. That's 0.8. That's close to 1. So when the probability is high, the odds will be low. The odds against will be low. And that means that you're going to lose money. Or you're not going to make as much. Okay? So that's what you need to remember when you're talking about odds. You need to remember that odds are going to be in favor of the house, which is the casino or the racetrack. They don't want to give away their money. Okay, so let's do another one. Let's see what they got on their slides as far as examples. I don't know why this thing's running so slow. Determine the odds against rolling a 4 on a die. So write that down. Determine the odds against rolling a 4 on a die. Determine the odds rolling a 4 on a die. Okay, so I'm just going to, for giggles, I'm just going to write the die up here. You got a die with 1 dot. You got a die with 2 dots. You got a die with 3 dots. You got a die with 4 dots. You got a die with 5 dots. And you got a die with 6 dots. So what is the probability of rolling a 4 on a die? Probability of rolling a 4 on a die is 1 out of what? 6. Therefore, the probability of losing would be 5 out of 6. So now let's do the odds against. The odds against would be equal to the probability of losing over the probability of winning. Multiply by the reciprocal, and the 6's go out, and you've got 5 to 1 odds. 5 over 1, 5 colon, semicolon 1, and 5 to 1. Simple as that. Five to 1 odds. Next. The odds in favor would be the same except as you flip it. So if I wanted the odds in favor of this guy, if I wanted the odds in favor of this answer, the odds in favor would be 1 to 5. I'm not going to spend a lot of time on odds in favor because it's just the reciprocal of odds against. So if I wanted the odds in favor of this problem, I'll do it in blue. The odds in favor, I just take this answer right here and do the reciprocal. 1 over 5, 1 to 5, and 1 to 5. So that's why I don't spend a lot of time on odds in favor, because it's just the reciprocal of odds against. So if you can find the odds against, then you pretty much have the odds in favor. question so far? I'm just going to look and see what else they have on here. I know we're about out of time, but we got plenty of time. Not today, but we're okay on time. Okay, what is this? I don't believe I've seen this before. Oh, I see. Okay, the circle graph, I'll go ahead and put this. This is a standardized test question. The circle graph shows the U.S. smartphone ownership in 2014. So I want to give y'all a minute to write that down. Do a circle and just draw the triangles and just put the... So we've got Apple is 42%. Samsung is 27%. LG is 7%. Motorola is 6%. And HTC is 5%. Is that 5? Yeah. And other is 13%. So they want to know, there it is again if you need to copy it. If a smartphone owner is randomly selected, determine the odds against the individual owning a Samsung. The odds against owning a Samsung. So what would be winning owning a Samsung? So I'm going to take my handy dandy I'll go over here so y'all can still copy that down. Sorry. There. So I want to find the odds against a Samsung. That's the kind of phone I got. So, first of all, the probability of a Samsung is equal to 27 out of 100. 27% is 27 over 100. And that is our probability of winning, because that's what the question just said. Then therefore, the probability of not a Samsung is equal to what? 73? That's the complement. And that's the probability of failure or losing. So, odds against a Samsung is equal to the probability of failure divided by the probability of success. Multiply by the reciprocal. And our answer is, because the 100s cancel like they're supposed to, and that gives us 73 over 27, or 73 to 27, or 73 to 27. And that should be your answer. And that's a test question. So let's look and see what they got. And let's go to the next slide. $73 to $27. All right, let's call it a day. The next thing we're going to be doing, let's see what's left. There's only like 4 slides left. Yeah. Yeah, this one's a good one. This one right here is a good standardized question. So I think they ask another question here. Okay, let's just restate the question. So we're going to do that last slide. Okay, so you should be able to start working on 11.2 now and start working on those odds. We only got one question left. So does anybody have any questions?
No, sir.
Okay, well, y'all are good to go, and I will see y'all. Now, let me go ahead and tell you this. We'll probably finish up 11.2 Friday. So that means we'll probably work on questions, homework questions, and tests on Friday and Monday. So that means that your test is going to start Monday probably. Y'all got any questions? All right, y'all have a good day.